Well, welcome to the Zoom session for week 3. Just a confession to make, I've had a tech fail, so I'm having to redo this recording rather than post the live one. So where possible, I'll add in the relevant questions and do a bit of ad-libbing so that we get going. The representation there is a Year 4 student representation of science, and our focus this week is learning and teaching scientifically. Most importantly, that final line, science should be taught in ways that recognise the limits of present understanding. And that can be cultural, it can be knowledge-based, it can be year-level based, and it can be also a curriculum issue. The learning outcomes, we've got a very young Einstein there. As you can see, our aim is going to be to describe, explain, and identify. Always good things to do. Housekeeping matters, couple of things. Census date is March 28th. If you've got some issues with your enrolment, workload, work-life balance, now is the time to think about what those issues may lead to and what decisions you make about your future. After March 28th, it gets harder to withdraw without penalty, so please do think about that now. We also ask you to try some discussion board narratives activities this week, to select a conflict area and share your response idea in the discussion board. It's a great opportunity to get some of your ideas out there with your colleagues. Q&A stuff up. What came up this week? Cosmos and Mythos, a little more explanation required, no problems. Week summary, I'll try to do the best I can. Mythos and Cosmos, well, Mythos is basically mythology. Cosmology is science, the tools. Now, cosmology are the tools that our mythology creates. So there's a paradoxical relationship there. Tribes had mythologies. The shaman, for example, would have a dream. A dream would give rise to certain deities or spirits. Those spirits would affect the lifestyle and decisions, where the tribe lived, what they ate, how marriage was construed, medicine, all of these different things. We can see the relationship between mythos and cosmos creates community, structures science, and embeds scientific method, particularly when we get to the Greeks. Okay, the Greeks had a rich mythological framework. We had Zeus, we had, Cyclops, we had Ulysses, we had all of these great characters, but they were mythical, and their feats and their accomplishments gave rise to a cosmology, that is, a scientific way of understanding the world, everything from travel to astronomy to geometry to mathematics. The Greeks weren't the first, but they're certainly perhaps the most documented, and that's a cultural thing. Joseph Campbell, American author, a mature cosmology needs a mature mythology. If you don't have both, chances are you're finishing up with some very huge blind spots. And we can look at this, the difference between science, and our example here this week of Galileo, confronted by the Christian church at the time, and accused of being a heretic for suggesting that God didn't create the earth alone. Man wasn't the most important thing in the universe. In fact, there are a whole lot of other planets out there, and if you look through my telescope you can see them. Of course, the Pope shouted back, no, all I need to do is read the book. And ever since then, we've had this incredible tension between mythology and cosmology. The God mythology has actually restricted the scope of science to grow and expand in certain areas. We only need to look more recently at Africa, at birth control, at food sustainability, at HIV, at global epidemics. We can see in embryo experimentation, all of these different things where the church has a role and has a position, and science also has a role and has a position, and often the twain shall never meet. However, cosmology has continued to thrive. Our physicists and our neurophysicists are opening up new scientific possibilities and realms. Chaos theory, we can see the gap opening between these different fields, and we're coming up with new scientific fields and understandings all the time. Scientific understanding is also doing this incredible U-turn. It's looping around to bring in things like mythology, like indigenous culture, like indigenous perspective, like American Indian perspectives. Even the Grimm's brothers have a huge amount of information to contribute to sciences, particularly our psychological and social and anthropological ones. Why do we do what we do? Key terms: narrative, hypothesis, and models. Narrative, the message is we've got to find a way to tell a story about science in order to teach it. Hypothesis, the old way, okay? An educated guess, And what we do is we try to continue to test that guess until we disprove it. If we don't disprove it, it must be true. Inductivism. Models are sets of theories that are widely accepted. Notice, widely accepted, not universally accepted. We still have a flat earth society. Open up Dr. Google, put in the 2 words, or 3 words, flat earth society, and you'll find they actually have a web page. The key questions: what is scientific method? How does evidence support a theory? Is theory change in science a rational process? Or can we really be said to know that scientific theories are true? And again, it's not a rational process. Sometimes it's by pure luck. Sometimes it's by design. Sometimes it's accidental. The demarcation Francis Bacon started as breaking science down into different fields. In other words, he said we can understand everything through observation and induction. And that just gives rise to understanding things differently, different strands and different substrands of science. Things like homeopathy, which in the old days, alchemy, you may have heard the term, creating gold, turning liquid into gold, used to be a science, believe it or not. The world's greatest minds used to ponder away day and day and night and night, locking themselves in towers trying to convert raw substances into gold. So we can see science has a rich history. Science is constantly observing, inducing, proving, disproving, and working its way towards truth. And the hierarchy is here: observe, hypothesis, experiment, create or test a law, and from that law shall derive a theory that can be applied more generalizably and more widely. Illustrated, it looks something like this. Hypothesis is formed, data is collected, it's falsified, a new hypothesis is formed. Okay, the hypothesis is supported. An experiment is set up, it supports the hypothesis, and we analyse the results, and again it goes round and round in circles. Nothing is ever final in science. As a result, there is no such thing as a presuppositionless observation. You may look at that and see a hexagon. You may look at that and see a cube. You may look at see trapezium and triangles linked together. You may see a diamond in the centre. What you bring to it is what you will see. We went through a series of unrelated shapes and showed that when we put those shapes together, a clear relationship emerges. However, that relationship links to a different technology, a technology of literacy, to form a word. We can see the image on the left, the old crone or the young woman, or is it both? And we take science and we look at umbrellology, tricky word. Can I make a science out of the study of umbrellas? Can I do a PhD in it? Can I go around different countries of the world and look at how umbrellas are used, how they're built, how they're created, what materials they're made from, who owns them, male, female, what colours they are, how often they're used, how often they're purchased, what they say about our social status? Is umbrellology a science? You could be the first PhD. Bertrand Russell's Inductivist Turkey. A nice summary, this, and this he told to a group of scientists and their children on Christmas Day as they all sat down to carve up the turkey. The story of the Inductivist Turkey who discovered he was always fed at 9 o'clock, and he formed his own science around that. He collected data, he analysed the data, he made observations, he charted these. Okay, he charted the temperature, the variations, every day it happened the same. He just declared, I'm always fed at 9 a.m. However, the next day was Christmas, and instead of being fed, he was feeding others and had his throat cut. So it was a really tragic tale, but Bertrand Russell in the 1920s was a fairly humorous philosopher and a brilliant man and mathematician. And his theory was that, science is not a body of knowledge, science is a testing ground. Our weekly textbook activities. We're looking at how chemistry and science has changed over the years. And an old favourite of mine is Professor Julius Sumner Miller. And I played it for the group this morning just briefly. And here is Julius Sumner Miller. This is what science looked like in the classroom in the 1970s when I was there.
Professor Julius Sumner Miller, Professor of Physics at the University of Southern California.
Consider this stick. Okay? Stick like a meter stick, like a yardstick. Let us call the stick uniform, homogeneous, and isotropic. How do you like that?
Let us call the stick uniform, homogeneous, and isotropic. Look at the body language. You can see the large man standing there with his hands crossed, very uncomfortable. Professor Sumner Miller looks like he's got a weapon there, and he's about to torture this man with science. So it's a really interesting representation. Science was an instrument of torture in the 70s, and not necessarily such an exciting worldview. Another task, share 2 major discoveries. Here's a couple I found for Activity 3. A new organ in the digestive tract. We used to think the stomach or the digestive tract was one system of digestion from the stomach right down to the bowel. In fact, we're discovering it's made up of several different parts, and in discovering that, they've actually discovered a new one right in the middle. The second one down here is a solar system of 7 Earth-sized planets. Again, discovered late last year, publicised early this year for the first time. And again, perhaps the future of space science is heading towards this little galaxy of planets. So we're starting to see science making new discoveries every day. And again, those discoveries are sometimes, for instance, one that touched me recently was, you're all probably familiar with the plight of Tasmanian devils. They have this facial tumour that's wiping out the species. Well, scientists have actually come up with a genetic cure for it. So, and that happened only 3 weeks ago. Major discoveries. Science is out there doing these things. Where to find more information about science? Now, if you're really going to be telling science stories to your students, you need to be able to find these stories and have this information, because you are only as good as the narrative you can share. Now, the more you're able to share about something, the better your narrative. And the better your narrative, the more convincing you are as a teacher. This website I've shown you here is a really, really good one for you. And part of my role is to throw resources at you. Sometimes you'll be like, it's Teflon and nothing will stick. But sometimes you'll actually look at it and say, that works for me. That's a good resource. And this one's got astronomy, biology, physics, geology stories. It's the stories behind the science. It brings the scientists to life. So you can talk about people like Charles Darwin, who as a child, had such an insect collection. It was phenomenal. His whole room was filled with insects, and one day he found 3 new insects he didn't have, but he only had 2 hands, so he put the third one in his mouth and ran 6 miles home, so he could pin them to his pinboard. I mean, these are amazing stories that kids get. Kids say, tell me more, tell me more. It's really exciting stuff. A great web page. It's also got support materials, how to work with science, how to work with groups, small groups, and how to conduct project research. So it's a really, really useful site. I won't go into it and dwell on it too much. Just point it out to you that it's the story behind the story, and that's what we're talking about this week. The narrative of science. How to use science, how to communicate it, how to bring it into the life of your students. Scientific views, activity 4. How is science viewed historically? Now, for this reason, we've looked at 3 basic perspectives: the indigenous, the early Christian, and the Muslim. The Muslims were brilliant. As I said, they existed around about the time, well before Genesis was written, and they were a very scientific community. However, the people that wrote Genesis didn't really want to focus on science. They wanted to focus on fundamentalism. So we produced a version of creation. In the beginning there was God, and God was the Word, instead of, something more elaborate, which the Muslims were actually very aware of at the time and preaching. So we finished up with a restricted or a limited mythology versus a more advanced mythology that we would have got from some of the Muslim states. Not a bad thing. Doesn't mean anything, it just simply was. But the Muslims were very much into technology at the time. Coins, numerical systems, mathematical instruments, all these things that they were using in great depth. The early Christians were much more tribal, much more scattered, and probably not quite as elaborate. Then we have the indigenous perspective, which I've left till last. And to talk about this one, I've actually presented a little link here to a video that I really enjoy. It's Damari and the Crocodile, and it's a creation story about the 2 spirit brothers and when they come to Earth. And here's just a little example of a lot of parallels to the Judeo-Christian mythology. Here is how the video begins.
A Maladumban, always trying to trick his brother. Is Gimela, fire sticks, we're no good.
Now, The story is a beautiful story, and it's a wonderful narrative, and it goes on to tell the story of creation from an Indigenous perspective, particularly the Bummer of North Queensland. And they talk about Ganyara, the crocodile. Damari stumbles across Ganyara. Ganyara has no teeth, so Damari carves some for him. He's a real trickster. And Ganyara really wants to taste meat, so he ultimately carves him the teeth. The crocodile gets his teeth and, of course, bites off Damari's leg. And hence Indigenous people know to be very wary of crocodiles. It's in their blood. Ultimately, Damari dies. He climbs to the mountains behind Cairns, but on the way, blood spills from his wound, and the blood gives rise to the ecosystem, and it creates basically all the birds, the wildlife, the trees, everything that we know and love about far North Queensland. It's a beautiful creation story. Now, is it a science? Well, the Great Serpent story, too, is common to many Indigenous communities. As a matter of fact, at this stage, I think anthropologists have yet to find a tribe, an Indigenous tribe in Australia, who doesn't have its own version of the Great Serpent story. So these are narratives, scientific narratives. Yes, they're social narratives. Yes, they're stories of dreaming. Yes, they're stories of spirituality. But for each of the groups, Muslim, Early Christian, Indigenous, they're a narrative. They represent what we call paradigm shift. Science has its own narratives too. We had Aristotelian physics. It gave way to Newtonian mechanics. We started to focus more on the physical world. We saw geocentric versus heliocentric model of the universe. Copernicus in the 12th century, stood up to the Pope at the time and said, "Sorry, Pope, the sun doesn't rotate around the Earth. We're not the center of God's creation. In fact, we rotate around the sun. It's not all about you, buddy." That was the message. The Pope, of course, and the Church didn't like that. And we saw that repeated again with Galileo in the 16th century. So it's important to have a good look at these stories. These stories are paradigms. The Darwinian Revolution, Darwin is a devout Christian. His wife was even more devout. He almost apologized for discovering evolution. And the only reason he published it was because he was frightened in the end that other people would beat him to it. Einstein's theory of relativity, as one student in the chat actually pointed out, it's also being challenged now. We're moving more towards quantum mechanics and theories, chaos theories. We're starting to see the interplay of physical theories and physical forces in ways that we've never seen them before. Heisenberg's uncertainty principle, and by there I'm not referring to that fabulous show Breaking Bad, where Heisenberg was the villain. I'm actually talking about Heisenberg and his uncertainty principle and his principle instability. So if you're not sure what that is, please Google it, and it's not about Breaking Bad. The narratives task. Now, we had a good look at the narratives task in the session online in Zoom, and I do apologise for the failed recording there, but hopefully this will fill some of the gaps. And you had to select one of the conflict areas, and mining is, what we're sitting here listening to the Palaszczuk government at the moment, and a group sprung up this morning comprising 13 major Australian organisations who are moving now to stop the expansion of the Dani mining project. So we're seeing a real social conflict around mining, so it's an area of conflict. Breaking it down, exploration, you can see the vertical structure here, what mining is. We can then see the intersections where we have scientific or social or human interactions. It's an example simply of using a narrative to talk about a principle. Now, why are we doing this? We're basically doing this to say, if you can talk about a principle to young people and young minds, you can teach about it. You can create intersections. What is high quality ore? Where is it found? What does it look like? What is its content? How do we get it out of the ground? We can look at some of these processes, geology, the mineral extraction processes. We can design experiments around them. You can see here how a simple understanding, a narrative understanding of a simple task, of a conflict, can lead to scientific investigation. And isn't this what we're supposed to be doing? Creating hypotheses? The following concept map. The team this morning really got through this. They did very well, filling in the gap. Zinc, of course, the symbol for zinc is capital Z, small n. And the uses for zinc is basically it's used in other metals. Brass, nickel, silver, aluminium, solder. Zinc oxide is usually used in manufacture of paints, rubber, believe it or not for you girls out there, cosmetics, often in drugs that we take, pharmaceuticals, plastics, inks, soaps, batteries, and sometimes in electrical equipment. So it's a broadly used product, okay, and got to do with its physical properties of conductivity, etc., etc. Iron reacts with acid to form what? Hydrogen gas, of course. Aluminium, physical properties. Well, how do we describe it? You know, depends what... It's shiny. You may want to use shiny as a narrative term. It's silver grey. You may, when you're talking to chemical students in year 11 or 12, it's got a density of 2.7 grams per cubic metre, centimetre, sorry. You may want to talk about touch and feel. It's ductile, it's malleable. It's got high tensile strength if you're talking to a technology class. It can be solid at room temperatures, but it can melt at extreme temperatures of 4,566 degrees centigrade, so Fahrenheit. Sorry, it's there's a range of narratives you can find to describe science and to elaborate. So your task as a teacher is to find them, to find age-appropriate and framework-appropriate narratives. Down the bottom link here, I've produced a wonderful narrative which I often and always enjoy and promote to people just to get an insight into science. It's produced by Phil Hellenes, and it's a powerful account of the magic of science and it's how it's worked in his life. And I'll just play a little bit for you to give you an example of the power of narrative. When narrative comes to science, what it can achieve.
But you've got to have the knowledge. Seeing is only half of it. That night 3 years ago, I knew a small part of what's out there. The kinds of things, the scale of things, the age of things, the violence and destruction, appalling energy, hopeless gravity, and the despair of distance. But I feel safe, because I know my world is protected by the very distance that others fear. It's like the universe screams in your face. Do you know what I am, how grand I am, how old I am? Can you even comprehend what I am? What are you compared to me? And when you know enough science, you can just smile up at the universe and reply, dude, I am you.
That's a wonderful phrase, isn't it? When you know about science and the universe says, who are you? Do you even know what I am? And you can smile back at the universe and say, dude, I am you. A really powerful account. And this is a narrative, a deeply personal one, and one certainly that would be relative to a range of different perspectives, whether you're teaching philosophy, whether you're teaching English, whether you're teaching science to a higher level science class. Probably not age appropriate for younger people, but you can see the power of narrative as an example there. Activity 7, pick any object. Any object. In this case, Linda's picked a tent. And apply 5 activities to investigate science and technology of that object. And you can see here a tent. Okay, a tent we hope is waterproof. Most of the ones I've slept in haven't been. And even if they were, water tends to come from the bottom. So, really interesting. Second thing, living things need to shelter to survive. And you can place some experiments around that. Ice in a cup under a variety of shelters. Look at the time it takes to melt. Mass supported by poles and shape. Okay, what sort of design is going to give you the best strength? And you can do that with a really small, you don't need to have tents to do that. You can do it with Lego, for instance. You can do it with paddle pop sticks and large books or small computers. The strength to withstand wind. You can use a simple fan. You can use a fan that's got 3 different speeds. Storage. Again, you can simplify the task. You can bring it down to a narrative that is easy to communicate and easy to share. Give this a go. This is a real testing point for this week. Because if you can actually produce activities around an object, you're 3/4 of the way to teaching science. The Need for New Stories is a blog. It's based on a TEDx presentation. And this young man, Atif Wasadia, is a young scientist who teaches science to young children, and also a research scientist. And he talks about the need for science to come up with new stories. It's about not about knowledge in fact. If we look at, for instance, if you look at a photo of Bob Dylan when he was 20, look at a photo of Albert Einstein when he was 20, and they look like brothers. They look like twins. They could be the same man. Yet our image of Albert Einstein is of an aged man with unclipped eyebrows, with a huge moustache and messy hair and a crumpled suit. That's what science looks like Professor Julius Sumner Miller. Now we need to challenge those, and this is a wonderful. It only goes for 8 minutes. This YouTube, not compulsory, but it may help bed down this week's material. Okay, so it's a good one for you to look at. And he's got a lot to say too, and provides in the article on the blog some really good references to other sites where you can find stories in science. And the better you tell a story, and we know this from our early childhood teachers, it's really not what we call science. It's about the science of storytelling. If you can tell a story, then kids want to know more. They want to know more. You know, Snow White wasn't a myth it wasn't a parable about 7 small men. It was actually a parable about a woman, a young woman, going through a stage of life where she could no longer relate to her mother. Okay, who's psychologically represented by the witch. So it's a really, really rich narrative, not just a story. The assessment criteria. Now we got to this particular point, and around about this time Katie asked a really, really good question about Galileo's experiment with the feather and the rock, and how ultimately Galileo was proven valid when that experiment was finally replicated on the moon, in the first landing of the moon. And again, that's another wonderful narrative. Think about it. You know, when they land on the moon, Neil Armstrong doesn't say, well, here we are, this is the moon. He sort of says, one small step. Well, he says something about a small step and about a giant step for mankind. So you can see the narrative explodes. It explodes and explodes the science. And everybody then, you know, the music swells in the background. You can sense the power of the narrative. So I've actually suggested to Katie she Google that experiment and see what the real story was. Because what a wonderful way to teach it. Knowing that, you know, when this experiment was conducted on the moon, that it actually had to relate to someone back in the 16th century. Someone who challenged the church at the time and challenged established knowledge. And sort of said, wait a minute, I'm going to create a paradigm change here. The world is going to move away from looking at the church, and now it's going to start looking at science. Astronomy. It's not just about a Bible. Wow. How confronting. The assessment criteria. Down the left side, we can see it's all weighted. Now, we had a few good discussions on this. A lot of people are comfortable with the criteria, so I'm not going to spend a lot of time picking through it. All I'm going to say is that it's weighted, and you can see that criteria 1, criteria 3, and criteria 4 are where the bulk of the marks are. As you can see, 40 of the 50 marks are embedded there. You can see exactly what those criteria are. Explanation of a chosen issue in contemporary science education and pedagogy. You can see the second one. Knowledge of the understanding. K and U of content, concept development and teaching strategies. So here is your curriculum links. Explanation of a chosen issue in contemporary science. Now it's really important here. Which issue will you choose? Well, look at criteria number 2. It says a key concept in either biology or earth and space sciences. Explicit identification of a key concept in either biology or earth and space science. So pick one. Don't try to do all 3. If you try to do all 3, you're not going to have the depth to demonstrate your knowledge and understanding in the next criteria of teaching strategies that can be applied to a key concept in one curriculum area. Remember, you've only got 20 slides. You haven't got a textbook like Gregson. You've only got 20 slides. Criteria 4, demonstrate understanding of experience, culture and or scientific knowledge of Aboriginal and Torres Strait Islander peoples. Now this is in there because that is a curriculum priority under the Australian curriculum. So as you can see, it's been allocated 15 marks. And particularly in North Queensland, there is a very strong likelihood that you are going to need to be quite competent in this capability as you go forward as a teacher. you are going to have Indigenous students and cultures in your classes. And you can see the level of performance varies too across the scale. We can see elaborate, appropriate, either strand clearly identified. Knowledge and understanding is deep. Sophisticated and accurate understanding. Sophisticated level of the Peshakusha. Okay, it's extensive style of relevant and credible resources. So we can see here that, you know, in order to be at the left-hand part of the scale here, in the higher achievement levels, it's going to require an elaborate explanation, an identification of one clear concept. That concept's going to need to be linked to your topic and your theme. So you'll have to identify the relevant curriculum, content, and concept development and teaching strategies. You're going to have to include some aspects of Aboriginal and Torres Strait Island culture. And you're also going to need to present in your images authoritative sources that present science as being enjoyable, as being fun, as being playful, as being inquisitive, and being inquiry-based. So you don't really want to find a group of Year 12 students laughing and rolling around the floor. That's not enjoyment. But inquiry. You know, you may want to use images of inquiry or inquiry processes. You may want to find images to support. I won't say any more. I'll leave it with you. Suffice to say that on the live recording this morning, we had some very good questions around this criteria and some very good observations. So my apologies at that fail. And certainly I'll try and work out why. But Zoom just clocked off on me today, so I apologise. Please use the Q&A for any questions. And I encourage you to either use the Q&A, email me, or please speak to each other at the very least. Thank you very much. And at this point, I'll end the recording and post it